Hello and welcome to this tutorial. In this lesson, we're going to study about the types of triangles, and we normally have 4 types of triangles, which includes scalene triangle, equilateral triangle, isosceles triangle, and lastly is the right-angled triangle. To be able to classify and categorize any type of triangle to any of these 4 major categories, you need to check on the uniqueness on its angle size and also the side measurements to be able to determine what type of triangle it is going to be. But before you look at those unique features, we need to look at one major property that is common to all the triangles. And the feature is that if you take the angles inside the triangle, you add them, should always add up to 180 degrees. For example, if I take this angle here, plus this angle here, plus this angle here, I'll get 180 degrees. Let us look at the first type of triangle, and we're going to look at scalene triangle. And a scalene triangle is a very special type of triangle in which has no sides equal to each other and has no angles equals to each other. We are going to use markers to illustrate that. That is, this angle is not equal to this and is not equal to that. As you can see, the markers I have put, this is 1 marker, 2 markers, and 3 markers. So 1, 2, and 3 means that none of these angles are the same. We are also going to use the markers on the sides of this triangle. That is, this side is not equal to this side, is not equal to that side. So we can use some letters to illustrate this. For example, let us say this one to be angle X, and this angle Y, and this angle Z. Then angle X is not equal to angle Y, is also not equal to the angle Z. That is, none of these angles is the same. That's the first property of a scalene triangle. The second property, if I have sides A, B, and C, as you can see with these markers, none of these sides is equal to each other, which means that A is not equal to B, is not equal to C. The last property, number 3, is that a scalene triangle has no line of symmetry. Has no line of symmetry. A line of symmetry is that line that can divide a shape into 2 equal parts or 2 identical parts. For scalene triangle, we don't have such a line. So those are the properties of a scalene triangle. Let us check the second type of triangle. Equilateral triangle has all the angles equal to each other, and also the sides are equal to each other. So I'm going to use the markers for that. I'll start with the sides. So this side must be equal to this side and must be equal to that side. I'll also use the markers for angles. This angle must be equal to this angle, must be equal to this angle. For instance, if this is angle X and this angle Y and this angle Z, then angle X is equals to angle Y and must be equal to angle Z. And for equilateral triangle, these angles are special. You normally find one of these angles is always equals to 60 degrees. So that is the first feature. The second feature is that all the sides are the same. That is, if I have this side A, this side B, and this side C, then side A must be equal to side B and must be equal to the side C. The third feature about an equilateral triangle is that it has 3 lines of symmetry. It has 3 lines of symmetry. That is, you can cut it through 3 lines to form 2 identical parts each time. For example, it can have a line of symmetry through that path. We can also have another line of symmetry through that path, and we can also have another line of symmetry through that path. So you have line of symmetry 1, line of symmetry 2, and line of symmetry 3 in that case. So those are the properties of an equilateral triangle. That type of triangle is called an isosceles triangle, and an isosceles triangle has the following features. We have 2 angles that are the same, and I'm using those 2 markers to mean that this angle is equal to this, and the other angle is different from the other 2 in terms of size. Also in sides, this side will be equal to this side, but this side is going to be different from the other 2 sides. I can use letters to illustrate this. So if I call this one the angle X, and this angle Y, and this angle Z, and this side A, B, and C, the first property is that side A should be equal to side B, but should be different from side C. And the second property is that angle Y must be equal to angle Z. So angle Y must be equal to angle Z. The third property is that an isosceles triangle has one line of symmetry. One line of symmetry. That is, you can cut it through a single line through here to form two identical parts. I also need to mention some few things about an isosceles triangle. There's two sides that are equal. They normally meet a baseline. And the angle that is going to be formed by the baseline and the two sides that are equal is normally referred to as the base angles. And we normally have two base angles, like in this case, Y and Z are the base angles of this isosceles triangle, and they are always equal to each other. Let us look at the last type of triangle. And the last type of triangle is the right angle triangle. And we normally have two types of right angle triangle. The first one is an isosceles right angle triangle, and the second one is a scalene right angle triangle. We have already talked about the isosceles triangle and the scalene triangle. So let's look at the features of an isosceles right angle triangle. I'm going to use the markers to illustrate that. For an isosceles right angle triangle, if we have an angle of 90 here, and always remember that a right angle triangle will have one of the three angles being 90 degrees, and use this symbol to represent an angle of 90. So this is 90 degrees, and also for this triangle here is going to be 90 degrees. For an isosceles right angle triangle, the features are as follows. The two sides that joins to form the 90 degrees, they are always equal to each other. And the side that is directly opposite the 90 degrees, which is called the hypotenuse, is different from the other two in terms of size. And therefore, we have an isosceles right angle triangle in which we have a base angle of this and this, which are going to be equal, and one of the sides is always 45 degrees. 45 degrees. So which means we have the following features. That is one of the angles, and I'm going to use some letters here to represent that. So I'll use this one as X, Y, and Z. So you see one of the angles, which is Z, is equals to 90 degrees. Then the angle X should be equal to angle Y, and each must be equal to 45 degrees. The second feature, I'm going to use the sides. I label this one as A, B, and C. And for an isosceles right angle triangle, A will always be equal to B, but should be different in size with the side C. In terms of symmetry, an isosceles right angle triangle has one line of symmetry. That is, you can only divide it through one single line to form two identical parts. And that is through the angle of 90 to cut it into identical parts. This part should be equal to these parts. Let us look at the second type of right angle triangle, which is a scalene right angle triangle. I'm going to use markers for that. So this one resembles 90 degrees. Then this one I'm going to put one marker to mean it's different from this. And I'm also going to use two markers here to mean it's not equal to 90 is not equal to this angle. I'll also use markers on the side. So this side is not equal to this side, is not equal to that side. Then I'll use some letters to illustrate that. I'll have the angle X, and there's going to be angle Z, and there's going to be angle Y. Then I'll have side A, side B, and side C. Using the details of this triangle, now we can look at the features. And the first feature is that one of the angles must be equal to 90. And therefore, you can see Z is equals to 90 degrees. And the other two angles, that is the angle X, should not be equal to 90, and they should not be equal to each other. The second feature is about the sides, and you're going to find that no side is equal to each other, and therefore A is not equal to B, is not equal to C. And the last one is about the line of symmetry, and a scalene right angle triangle has no line of symmetry, has no line of symmetry, which simply means there is no way you can divide this shape to get two identical parts. And that brings us to the end of this video. I hope it's going to be of help to you at some point. Thank you for watching and hoping to see you next time.